Hi, everyone. Thanks for coming. This is the second edition of our new running PCC forum. I'm still admitting people, so thanks for all joining. I'm super excited about this one because there's so much synergy between Jack and Kerri. I'm taking a class with both of them, and there's just so much overlap. And I remember during Kerri's speech or presentation at Esalen, there was just a lot of overlap with your conversation questions. And so I was like, this is a great way for them to actually have a one-on-one dialogue. And today we're going to be speaking on the philosophy of math and sacred geometry. So I would like to start by introducing Dr. Jack Bagby. He is an expert in ancient Greek philosophy, an expert in 20th and 21st French philosophy, and we all know him as spearheading the Bergson Renaissance at the moment, which has been a wave of influence with just about everyone in PCC. He is, I mean, from my experience, a Deleuze scholar, I would say, and someone who I've been working closely with for a while now, and yeah, a huge influence on me. And we have Dr. Kerri Welch, and I feel that Kerri's introduction is just not on par with how I see Kerri. She's a philosopher of time, mind, and physics. We know her as the physicist of PCC, and she's the author of A Fractal Topology of Time, Deepening into Timelessness. However, I see Kerri as not just this crux between physics and poetry, but this essential bridge between the two. And Kerri's influence on me is profound. I think her book, A Fractal Topology of Time, is one of the most impactful books that I've read in my life. And she knows how much her work means to me. She offers courses on archaeoastronomy and sacred geometry through the Fox Finding Fellowship. And of course, she's an adjunct professor at PCC and CIIS. So, Kerri, I have a question to start us off. There's often a historical tension between mathematics and metaphysics.
Before we fully jump in, Afshin, do you want to do a little meditation to
Yes, I
drive
forgot about
around?
that. Would you like to
Okay.
guide us through that?
Cool. Yeah. So just taking a second to drop in and closing your eyes and finding a good position for your body, whatever feels like what you need in this moment. Just letting your attention come to your breath. And just noticing how it shifts when you give it your attention. Maybe you can feel your heart rate under your breath like I can. And maybe just counting for your inhale and exhale, just naturally noticing whatever that count falls to, rather than choosing one to adhere to. Maybe noticing the pause at the top and the bottom of the breath. And allowing that to be a space without counting. So just counting the inhale, pausing, counting the exhale. And then just noticing if there's one number or place in the breath that draws your curiosity, and holding that number and that place for a moment longer. Before moving on. And maybe noticing the parallel of that number and the feeling of that number on the in-breath and the feeling of that number on the out-breath. And then just letting go of any thoughts, taking a few breaths undirected. And opening your eyes whenever you're ready.
Great. Thank you for that, Kerri.
Yeah.
Get us grounded for whatever abstract metaphysics we fall into now.
Exactly.
So the question I'd like to start us off with is, there's often a historical tension between mathematics and metaphysics. Math is typically associated with clarity and formalism, while metaphysics is seen as speculative or even mystical. Yet we also find moments where mathematics becomes a source of deep metaphysical insight, from Plato to Leibniz to more recent explorations in category theory or process philosophy. And I'm curious, how do you see this relationship between mathematics and physics? And also, do you think there's a mathematics within metaphysics? And if so, are there particular mathematical structures or systems that you think lend themselves especially well to metaphysical interpretation?
Rich question. I could just do a brief one unless you got something on the tip of your tongue, Jack.
No, go for it.
Okay. The division of philosophy and mathematics and philosophy and science really is something I find very painful. When I first started taking philosophy courses in undergrad, I signed up for a metaphysics class, super excited. And I couldn't believe we made it the whole way through the metaphysics course and never talked about relativity or quantum mechanics or any type of physics whatsoever. And so this divorce that happened between philosophy and physics, where they used to be very integrated, obviously, and I guess I would say pre scientific revolution, probably. And the tendency of our mind to want to divide and analyze and narrow in. Math and science kind of went one way with the quantification of everything and eschewed the more philosophical, speculative, while still utilizing it to advance itself, but not explicitly acknowledging it. And so there's been this division of these two things, which go hand in hand, as we all know, particularly in this program, and that need each other to continue to advance the dialogue. And so I just like to bring them in dialogue whenever possible. And I'll hand it to you, Jack.
Yeah, that's great. And I agree wholeheartedly with what you've said. And one thing I want to mention first is that ever since my first semester teaching here, I've had students in your class, in my class, say in the class, "Oh my God, you have no idea all the connections that I'm making between your two classes right now." So this is really cool to be here with you. And yeah, I mean, I was thinking actually during the meditation when we started about counting and countability and quantity and like the relation, like what it means about something if it's countable, right? Like what does that actually say about some being or its reality or but yeah, and so there's all these questions with that about around quantity and the meaning of that and this very carnal embodied activity of counting things and relating to things in terms of counting them and counting our breath. Um, but there's a whole bunch of other concepts within mathematics that I think are really rich in for philosophy. And there is this tension between quantification and reductivism, trying to quantify everything and think that everything can be understood in terms of quantities of force and things like that. But there's a rich plethora of other concepts within mathematics, both within the world of finite things and in geometry and in number and in form and relation, as well as in infinity, which I think is really a kind of like endless wellspring of philosophical insights. And really, like all of my favorite philosophers, going back from the ancient to the contemporary, like infinity is the most important thing. And like, you know, going back to Archytas, who was a Pythagorean, who said, go to the edge of the universe with a stick and pop the stick out further and see what happens. Like we can of course take that in the very literal cosmological question about the infinity of the universe and stuff like that. But I mean, it's also an allegory for human venture to understand things and to palpate the infinite and to push beyond the limits that we um, you know come to through our understanding of things. And you know, the infinite, I think, just it's an idea that we think but that we also can't think because it's more than what we think, right? It outstrips what we can think, but also intercoursing with it is generative and generative of some of the biggest ideas, not only in philosophy or in like psychology or understanding the soul, but in theology and in the sacred and things like that, and in art. So to me, it's this kind of all-encompassing thread. And I'm teaching this course on infinity. And a few years ago, I taught it 2 years ago, but maybe 2.5 years ago, at one point, it just struck me like infinity is like the thread of all the ideas that I'm working on across the history of philosophy. I should make a class called Philosophy of Infinity, and just and so that's. But anyway, that's my quick answer maybe to the question.
Yeah, I was thinking back. Well, and I'm curious also, and I'm not sure. I don't use the reactions much in this, but if y'all want to find your reaction down there, I'm curious just of our audience here right now, what kind of mathematical backgrounds we're coming from. If and so I'm curious if you'd be willing to raise your hand if you have a more tense relationship with mathematics. If it's something that's scary or you were told you were bad at, or you have some kind of conflicting emotions around. Because this is often it's a very common thing for people to hear this word and like have some kind of intense emotional reaction to. And so sometimes it's helpful to just get an idea of.
I Yeah, I can totally jive with that because I was terrible at math growing up. I'm dyslexic, and so math was kind of. And I'm actually really good at geometry and spatial reasoning, things like that. But that's only a small part of math class. So I ended up doing really badly in math classes, getting put into bad math, like with bad teachers, and it stuck in a hole with it. And actually in college, I was able to get out of multiple of my math classes requirements by using Greek language as a filler, which is kind of a great little like liberal arts cheating way to get around doing math. But it was later that I came to these ideas through Leibniz, through Spinoza, through Bergson, especially related to the calculus and then things like nonlinear mathematics and the idea of the integral, which is obviously very important at our school, and thinking the conceptually around that. So just to say that conceptually, the ideas have become really exciting to me. I still get terrified with numbers and like can't do my math or my multiplication tables and these things. So what's
Yeah,
yours? Can you share?
yeah, absolutely, absolutely. I mean, mixed, right? For the most part, really solid education, really good teachers, definitely my bumps along the way. And grappling with, like, I remember at some point, like, my grade wasn't as where my mom thought it should be. She's like, I'm going to bring in a tutor. I'm like, I understand it. I'm just making careless errors. I don't care. And the
Yeah.
tutor said basically the same thing, that was like, I'm interested in the concepts, the implementation, let somebody else who's more detail
Mm. Mhm.
oriented, manage that part.
Mm.
And it was kind of interesting because in college I started with just philosophy and religion. But then I actually found CIIS PCC and said, oh, if I can do that with physics, I'm going to pick up a physics major too. Um, and so, but then of course I had sworn after I got done with pre-calc or whatever in high school, I'm like, that's it, never taking another math class again. But then I decided to pick up a physics major and it's just as many math classes as physics. So that was rough. It's hard. It's hard. But the beauty for it, and I love that we have some voices in the chat chiming in with, yes, I love math and appreciate it. I'm good at it also, those are the people to go to ask for help if you want. Or not really, because I've also found that math teachers are the people who it came very easily to. So they're not always the best at teaching to multiple thinking modalities. And that's often why people's relationship with math will tank, is because their brain wasn't working how the information was delivered, and it wasn't delivered in multiple ways so that they could find something to grab onto. There was another piece I was going to put in there, but it's gone now.
It is interesting the like expectation for mathematicians versus philosophers, where it's like sort of okay. Not that it's okay. I mean, there's needs for teacher. Like if you're a math professor, you also have teaching requirements and things like that. But I feel like the bar is lower, where like it's like, okay, well, you're a math person. It's okay if you can't teach this. But in philosophy, it's like, if you can't teach it, then we don't think you know it. Right. It's an interesting distinction where, I mean, there are people like Whitehead and things like that who create their own philosophical language where it's very similar to math, where it's like, if you don't understand the language, you're not going to understand the ideas, and you can't just make that accessible. You have to get into the entire system and work within the system. This is very similar for Leibniz and Spinoza, philosophers who are mathematicians, and we kind of like maybe give them more of a pass for these things. But I don't know if that strikes anything for you.
Yeah, well, I like that you brought up, that there are these specialized philosophical languages that philosophers come up with, which you have to really get in. You're like, okay, how are they defining this word and using this word and that? And you're learning a whole new vocabulary. And often, approaching mathematics, I tell people it's the same thing. It's a language of relationship. And if you're just willing to go through one piece at a time and learn how it's defined and how it's related to all these other pieces, which is the same thing you're doing with philosophy. So I think it's totally legit that you get, math credit for philosophy courses.
Beautiful.
But yeah.
So I have a question. Jack, I know I don't remember exactly where he talks about this, but I remember Henri Bergson critiqued mathematical abstraction for distorting our experience of time and change, because so many mathematical structures seem to exist outside of time, eternal truths, unchanging forms, and so on. So is there a way in which mathematics can adequately capture the lived dynamic reality, or does it necessarily flatten it?
It's a brilliant question and really gets to the heart of like a lot of things I've wrestled with for a long time, because he does have a like harsh critique of quantification and its a bit like ability to give access to the reality of consciousness and life, and um, uh, what he calls intensive properties or intensive feelings, the feeling of intensity. And he makes this distinction between quantitative multiplicity and qualitative multiplicity. And on this idea of qualitative multiplicity, he sort of stakes his entire philosophy of spirit, of duration, eventually, and the Elan Vital and these things. But at the same time, he uses these extremely profound, you could call them analogies, but I think they're actually deeper than analogies in some sense, but analogies to the integral and the derivative and the differential, um, drawn from calculus, and the understanding of unity and continuity and infinity and multiplicity and all of these things are concepts that that he gets at through mathematics, and thinks that they are adequate to at least point us in the direction of understanding the nature of consciousness and the soul. So very briefly, like a quantitative multiplicity is something we can count, right? Um, but or measure, but a qualitative multiplicity uh, changes in nature when it changes in degree, you might say. So, and this is the same thing with intensive differences. Um, Intensive properties in general, we know in physics today and things like that, operate differently than other types of quantities. If you have, a bucket of water and you cut it in half, it's not half the temperature. Or there's all these kind of like force relations. Even going back to Aristotle, he looks at these questions of like, if you have a ship with rowers and you have half the number of rowers, you don't get half the speed. Oftentimes, at a certain threshold, and this idea of thresholds is like super important, especially for qualitative multiplicity. At a threshold, maybe the ship stops moving. Like you can't overcome the current or the weight, like of the mooring of the ship, whatever, what have you. So yeah, and then one step beyond that, this idea of the intensive and then the idea of the integral, for Bergson is an understanding of infinity, based primarily in the immediate experience of motion. So in movement, there are an infinity of possible stopping points within any movement, and yet movement is continuous or undivided, right? So there's this bizarre mixture of infinite and unity or simplicity. And the integral in Bergson's thinking takes this place of holding together an infinity without sort of totalizing it, without turning it into a quantity or closing it or making it finite. I could go further, but this is kind of where he starts. And it's important to mention that Bergson was a mathematician when he started his intellectual life and made advances in mathematics, but he was far more interested in what's going on in our consciousness when we think these mathematical things. So like the relation between infinity and unity that we think when we experience movement, when we coincide with movement. This isn't something like that we just abstractly think, because when we abstractly think about movement, we think about space and quantity and things that aren't moving, right? We think of a kind of symbol by which to understand the real rather than the real itself. But when we experience movement and when we move and change and become, and our consciousness is enveloping an infinity in its actual existence, we can come to like a firsthand understanding of what an integral is by integrating multiplicity in our consciousness, right? So he goes for this like much more profound look at calculus. Like calculus isn't just this way of abstracting and measuring things, but it's a fundamental aspect of consciousness itself, the power to integrate and unite infinity into something simple that is still infinite. But anyway, yeah.
So I'm curious, Jack, because just kind of coming back to Afshin's question about the does quantifying something inherently flatten it or deaden it, and I think it's a tool, right? And we can use these tools in many different ways, and we can forget that it's a tool. And in that sense, it might have an unintended consequence of flattening, of disregarding the qualitative experience of something. And so when you're talking about the thresholds, I'm curious if it's specifically, I presume it is because he's talking about a qualitative multiplicity. But the difference in degree, like the examples that you gave, could be quantified. And I'm thinking about intensities, specifically like physical intensities, like loudness or brightness, which our senses are actually logarithmically scaling, so a just noticeable difference in loudness or brightness is actually an exponential difference in absolute measurable brightness or loudness. And so that threshold where I guess maybe he's identifying the threshold as a qualitative threshold, but
exactly.
then could also have a quantitative measure.
Yeah, I think that's exactly right. Yeah. And I don't think I think we could go too far with Bergson if we think we shouldn't say that the threshold, the qualitative threshold, can be quantified. Like, I don't think that there's a problem with it being able to be quantified. Like, there are Bergsonians who would probably go too far with this and be like scared if we admitted that, right? I think that the point is like he was looking at these people like the just noticeable difference and things like that, like Weber and Fechner. I don't know how to pronounce these German names, but these people who were doing experiments on just noticeable differences and trying to quantify change in intensity within feeling. And he's agreeing with them to up to a certain point that there is a way to quantify differences within perceptual experience. But if we come to the idea that there's a quantity of change in the stimuli that results in the noticeable difference, then all noticeable differences become linked to a quantity of stimuli, and there's a constant there. And basically we lose all of the qualitative distinction because we have a minimal sensible difference in light, a minimal sensible difference in sound. And to be clear too, we have minimal sensible differences in different environments, right? So if you try and whisper to me in a loud room versus whispering in a quiet room, like the just noticeable differences will be different because the muscles in the ear actually like tense up and change, and like the decibel level is actually different. So we can measure all these things. This is true, but we kind of skip over something fundamental about consciousness, which is the non-measurability of qualitative differences between two different sensations, whether they're from different senses or even within the same sense itself. And then taking it even one step further, every experience that we have, like when we're doing the breathing exercise, you have valent aspects of our sensible experience coming in at different times. And there's this incredible multiplicity of what we're aware of that can come into foregrounded and backgrounded at different times. And every sensation is inseparable from sort of the totality of our psychical life, all of our memories, prior moments, like what came just before. And so when we talk about measuring these aspects of our experience, it's not as if we're, grasping at smoke. We are talking about something real, but we're only talking about a very small amount of what experience is, right? And like, so Bergson wants to say, our sensations does depend on our body and on our brain, but the state of our brain at any time is only a small subset of the whole conscious experience. Like, the same brain state could have multiple conscious states, multiple different conscious states present to it. And our psychical being far exceeds our conscious being as well, and exceeds what exists sort of quantifiably in the present. So Bergson doesn't want to throw out quantification and science. He just wants to place it within the proper ecosystem of a larger, you might say, metaphysical psychology that extends beyond quantification. And yeah.
Kerri, if you have something to add to that, go ahead. I also have another question.
I mean, I'll just say that I think of quantification as a way to deepen the dialogue and not the entire dialogue.
Beautiful. I think that's exactly, yeah, I love that. Yeah, one thought about this too, just quick, because like, you know, we talk about quantifying sensations. We can quantify, it's very useful to quantify pain, right? Like in a medical setting. But it's also super important to keep in balance in our thinking about it, the differences between different types of pain, different qualities of pain, or even the way that like certain moral and psychological pains differ at different times in our life, right? And the way that the embeddedness in the duration of our life, you know, certain things hurt more when we're young than they do when we're older, and certain things hurt more when we're older than they do when we're young. And the particular way that that makes sense and makes meaning in our life is bound up with something infinite and something that can't be quantified, and that is, yeah, our whole self in a way.
Yeah, and I think this kind of points to the the difference between infinite and finite games, right? And the game we are playing is an infinite game. We're never going to find an answer, hopefully, because it keeps
We'll be
the
out of
game in
jobs.
play and it keeps it interesting. So as much as we're able to gain knowledge and quantify and define things, there will always be more.
Yeah, exactly. And in a similar way, like naming an emotion, like Bergson goes against like the idea that emotions are this universal kind of general thing. They're this very particular thing that has a concrete being in each moment of our life. And really, we don't live the same emotion twice, like Heraclitus. Like all of our moments of our life are unique. But it's really helpful to name emotions and to talk about them. So like we can't like take the wrong, you know, just because at a metaphysical level, we need to be very careful with the way that we quantify and talk and conceptualize, doesn't mean that coming up with concepts and naming emotions and talking about things isn't useful, therapeutic, helpful, knowledge building, all of these things. So I think just trying to cushion some of Bergson's critiques, as Afshin mentioned, like we need these kind of abstract and conceptual ways of approaching things that mathematics gives us. And I think it's very true that we can get into a very unhealthy quantify everything, explain everything away through quantities, but we can get into just as unhealthy of a phobia towards quantification and abstraction and things like that. They are very helpful, even on the most affective and embodied level.
Yeah, I think about when you're talking about emotions, a talk Rick did for public programs a month or so ago, I think he was talking about, or I was struck in a new way in the way that he talked about archetypes as taking us over. And I like to think about numbers as mathematical archetypes, you know, and any mathematical equation is an archetype. It's a pattern of relationship.
Mhm.
It's a,
Yeah.
it's, you know, a way things relate to each other. And similarly, an emotion is an archetype, right? And this is
Mhm.
what makes mathematics sacred, geometry sacred,
Mhm.
is this ability to unite diverse entities into one pattern
Yeah.
that
Yeah.
relates across those diversities.
Mhm.
And the notion that he was talking about being taken over by an archetype, and I hadn't necessarily thought about it in that sense before, but
Mhm.
in the idea of like naming an emotion or naming an
Mhm.
archetype that we're
Mhm.
participating in, we're relating our experience. Well, and I was thinking about it kind of as, you know, canyons carved, right? Neural pathways, like uh, a well-run neural
Mhm.
pathway is easy
Mhm.
to fall into.
Mhm. Yeah.
And so an archetype is a cultural or even natural,
Mhm.
well-run neural pathway that it's easy to fall into. And
Mhm.
in that sense, it takes us over because we are following its path.
Mhm.
And so to recognize the path that we have fallen into, the emotion that we're experiencing, and to remember, oh, other people experience this
Mhm.
emotion too. How have they dealt with it? And I can find my way down that path a little more clearly.
Completely. Yeah, this reminds me actually of Plotinus, who I'm reading right now, who says that in a way, like these tendencies that you're describing, these potentialities, this archetypal thing, is the habits of the world soul. That the world soul kind of like opens up certain habits, and that these valences and the idea of habit actually, I think, relates to the idea of infinity for Bergson. And it seems like kind of a jump, but like enduring in a certain way, there's something indefinite about it, right? And this openness to repetition is something essential to the infinite and to the archetype, or even to the idea, right? Like if I have the idea of a triangle, I can encounter a new triangle, and right, there can be an infinite number of triangles. There's actually multiple types of triangle, and each of the types, well, not all of the types, some types only have one appearance, like an equilateral triangle, whatever. But like many of the types have an infinite variety within themselves, right? And so there's something simple about understanding a triangle and being able to understand new triangles where I'm not actually thinking an infinite number of things, but I'm somehow open now to an infinite number of instantiations appearing to me differently, but knowing that they're the same idea, right?
Yeah,
I
and
think
I
it's
like
just so profound. Yeah, sorry.
in the chat, Jeremy says there's only one triangle, and it's
True.
reminding me of the way I think about light, in that it doesn't
Mm,
experience time,
yeah.
temporal or spatial
Mm, mm,
differentiation,
mm,
and so there's only one photon. But we, as physical beings, in the midst of temporal and spatial separation, experience the multiplicity of
yeah.
photons.
Well, I think that's
But they're
beautiful.
indistinguishable, whereas the multiplicity of triangles are
Mm,
distinguishable.
mm,
So
mm, mm. But you still don't distinguish a difference in at the level of triangle, right? Like you like I don't know. I mean, and like the when we think of a triangle, like even going back to like Locke points this out, that we usually think of an equilateral triangle because it's just like the simplest one, and it's kind of just like it fits in a circle and stuff like that. But like if there's only one triangle and it's seen always from different vantage points, there's no vantage point that is the vantage point of all vantage points, right? And I think like we broach something so profound there that is like almost like the whole of Leibniz philosophy, which is that like the infinite is something that can be approached from an infinity of perspectives, and no perspective is the one perspective on it, right? Like if you have a totality that is an infinite totality, which is a contradiction in some ways, there's an infinite number of ways of taking that infinity, of approaching it and
but the
thinking it.
totality of the perspectives is maybe the one perspective.
But you can't take that perspective, right?
Can you
And the other
not?
thing is like it's like the stick on the edge of the universe. Like I mean, this is what I guess I would say is like the infinite is so infinite that you can draw more out of it than it contains, right? So the perspective that would take all the perspectives would be taking new perspectives at every moment. I don't know. We're getting deep.
I guess I can conceptualize of a perspective that is the infinity of perspectives.
Really? Okay.
Yeah.
Pitch it to me.
I mean, that's it. You know, it's just an imagining.
Yeah, true.
It's a God perspective. You know, in physics, it's the photon that is unified of all space and time, and is also making up all matter in differentiated space and time. And so it's just to me, the most fundamental truths are paradoxes.
Yeah, beautiful.
And so,
but so is the perspective of the whole static?
No.
Or okay, so then we're on the same page. Then I agree.
Or it doesn't have to be. You know, it is both and. That's always the answer.
Sure. Yeah. If you limit the infinite to not having the finite, then it's no longer infinite, which is one of these really crazy paradoxes about the infinite.
I'm looking at the chat now for
could I ask a question to you, Kerri? Like what do you think about the relation? So you mentioned like sort of the idea of like each number has a kind of archetype to it in a certain way, and like, you know, the number 5 and the number 6 and the number 7, when we look at each of these, we could say 6 contains 5, but like we barely understand anything with that. We understand so much more when we see the way that 5 relates to 2 and 3, and the way that 6 relates to 3 and 2, and like, or well, they relate to those numbers differently, and the way that they create different shapes, and the way that they do different things, and like you can find in each number like a distinctive character that is a form, right? And it reflects all the other numbers, and it relates to all the other numbers, but it has like, so there's this sense of like determinacy and archetype and form and these things. And then there's and so that's the preface of my question. And like all of that works its way into sacred geometry in really interesting ways. So what do you see as like the relation there between sacred geometry and the specificity of number as a form and the infinite, and the kind of dynamism and differences there?
I mean, I guess thinking of each number as kind of a nexus of relationship is just kind of a way that keeps coming back to me. And just kind of the way we've been talking about, or Leibniz's monadology, that every perspective is a perspective on infinity from one finite perspective. So each nexus of relationship, each number, has this relationship to the whole, as does each person, a relationship to the infinite whole that defines their identity and individuality by virtue of their position within the whole. In relationships within the whole. And so in that sense, it's, and this is why infinity is such a fun thing to play with, right? Because it's in all the, it's in identity, like how many pieces of myself can I take away and still be myself, versus how many of my relationships can I take away and still be myself. This nexus of infinity. Our position within the universe is our identity to some extent. It's a position it's a finite position within an infinity. Every little position has its own little,
exactly.
Indra's net dewdrop on the web reflecting the whole.
There's almost this way in which the multiplicity of intersecting and diverging ways in which something can be counted, right? Like the number 3 can be counted as a prime number, it can be counted as a whatever. Like I can be counted as a human, I can be counted as a philosopher, I can be counted whatever, as a number of different things. But there's also a way of counting me that is where I'm the only standard, right? So I'm the only individual in the class that I'm counted with it, right? And this
Yeah.
is like, this has been called concrete number and things like that. Like this is where we get into like Platonism again, and again, the idea of the monad, where the monad is the standard of itself, right? It's the number that counts itself and itself only. Um, I don't know. It's like you see how all the metaphysical questions of Plato and and all and like so many different people in history can really be boiled down to these like mathematical perspectives on it, especially with the idea of counting, um, and the idea of singularity, exactly as you were like just talking about.
Yeah, and maybe that's the well, a couple different things. I'm thinking about the edge between the, finite perspective and the infinite, which
Mm,
it's
mhm,
reflecting
mhm,
as,
mhm,
the
mhm,
boundary
mhm, mhm,
between the
mhm.
the individual and the totality,
Yeah.
as the definition of the individual.
Mm, mhm,
And then I'm thinking about the edge, going back to this between metaphysics and science, and
mm,
that it's the limits of science and mathematics where metaphysics becomes um, more helpful, interesting.
mm,
Yeah, what am I trying? I don't know exactly what I'm trying to
mm,
say in there, but there's something about where, and I think it's just different domains of authority. Like this is how I tend to think of the different structures of consciousness, kind of in
mm, mhm,
Gebser's
mhm,
methodology.
mhm,
Um, Mathematics living in the mental structure of consciousness.
mm,
And the integral is going to have more perspectives on
mm, mhm,
metaphysics and
mhm.
philosophy.
Yeah. Mhm,
And they're both legitimate in their realms
mhm,
of authority. And what's
mhm,
most interesting to me is how they interact
mhm,
and how
mhm.
they dialogue with each other rather than which is true
Yeah.
or more fundamental or
Yeah.
primary or whatever.
Yeah.
Um, and I think that, yeah, just
There,
the elucidation, it's like we can hit up on these limits and point to these limits of the finite and the
mhm,
infinite.
mhm, mhm.
Um, and we can say the same thing over and over and over again from every different
Right.
field of knowledge.
Yeah.
um, and then we can go into the depths of one field of knowledge. And I mean, it's all just saying the same thing over and over again.
Yeah. No, exactly. And that's the like infinite finite. Once you go down that rabbit hole, you find that it's like connected to every single problem. And yeah. Um,
All right, we need another question, Afshin. Actually, wait, no, hold on. I've got one more because I did see that you did an article on Bergson and the integral, and you touched on it a little bit about kind of the analogies he uses. I'd love to
mm,
hear a little bit more about. I wasn't able to access the article, but
mm.
just about what those analogies are and how you kind of relate to them or appreciate them between. Well,
Sure. Yeah.
and I will say, first of all, because this is a slightly more abstract mathematical concept, not everybody took calculus.
Yeah.
And so I will say that when I was taking my math and my physics in high school, I was like, the math, I was like, the math was okay. I could do it, but it wasn't enthralling to me
Mm, mhm,
until I took physics. And then I
mhm,
was like, oh, this is what a derivative is. I can take the graph of a position of something, and to take the derivative of that shows me what its velocity is.
mhm,
Like, how is that position changing with respect to time? And if I take the derivative of velocity, then I want to know how that velocity is changing with respect to time, which is an acceleration or a deceleration. And
mhm,
so to have something tangible, because then an integral is just the inverse of the derivative. And
mhm,
so it's
mhm,
moving
mhm,
from acceleration, you take the integral of acceleration and you get velocity. You
mhm,
take the integral of velocity and you get position.
mhm,
Um, and so it's translating between um, different axes, basically
mhm,
changes with respect to a particular axis.
mhm, mhm.
Um,
Yep.
So I just wanted to say that in a preface before you go into, and maybe even the analogies will be easier to access than that, but to have a little, when I learned that that's what derivatives and integrals could do in physics, I was like, now I have a place to ground this information and it's not just mathematical hoop jumping.
No, exactly. Yeah. And yeah, the always for me the concrete helps to make these things interesting. And I actually I didn't mention this before, but I took physics in high school, even though my math was really bad and I was kind of like warned against it. And um I loved it and like really understood the concepts and like got somewhat good at the math, at least enough to pass the class and things like that. And I took physics again in high school or in college because I was excited about it. And like I could actually understand the concepts when they were within a fabric of concrete questions and problems and things like that. But yeah, I mean, let me give two like I don't know, descriptions we could say of how the integral and the differential and all of this uh, factor into Bergson's thinking. And one I'm gonna pull from Leibniz actually, um, which I think really helps. But so first would be to think about a curve. Calculus really, is a conceptualization of a change of change, which is a super profound sentence that took me a very long time to understand. So Bergson defines tendency as a change of change. Um, you can think change like a movement is going in a certain direction, right? We have movement in a line. That's a change. Now, if that movement in a line stops moving in a line and at every moment tilts its motion slightly, then it curves. And at every moment, it not only moves from one place to another, it also moves the direction of its movement, right? So it's a kind of doubly complex movement, a movement of a movement. This is what he says a tendency is. So if you have a body moving in a straight line, you have inertia. If you have something curving, you have tendency. So tendency is like the clinamen, not to get too abstract with like Greek metaphysical ideas, but the swerve within the fall of the bodies, which is this act of intentionality and uh, uh, unexpected change, we might say, the idea of the clinamen. But it's an added level of analysis to kinematics, to movement, right? To understand a movement as to understand a curve as a movement of a movement or a change of a change. And when you're driving a car around a corner, you feel the tension. Like it requires tension to continue to curve. And so there's almost like an interiority. Well, there is, for Bergson, there is this interiority of movement, a continuity over time. And it's a continuity that isn't doing the same thing over again in the exact same way, but is a change of a change, right? Now it's changing in the same way every time if it's a continuous curve. We can think of spirals and things like that that would change differently at every segment. And yeah, so basically, if we look at a curve, we have a multiplicity. We have every moment a different movement, a different kind of movement, and no two movements, no two moments are identical, right? You can't overlay two on top of each other. Now you can take tangents of each moment of the curve, and you have an infinite number of tangents, each one with its own unique direction. And there are very useful things, as you were pointing out, that we can do with this. But if we want to understand movement, if we want to understand curving as an action, as a kind of unified intention, we can't understand it through the tangents alone. So basically, a circle is not made out of a bazillion tiny straight lines, right? We can represent a circle as that. And we can always ask these questions like, well, are there any curves that actually exist in the world? Or is every curve a little janky line constructed thing? I mean, we can always ask, is any straight line ever actually straight, or does it wobble? You know, the same question that applies to the discreteness of sections of a curve and the impossibility of curving applies to straight lines, right? So can we say whether curving actually exists? This pushes us into realms where, you know, we have things like the Planck length, and we have these questions of, is there ultimately in the world something that is true continuity, or is every continuity actually composed of small, discrete, finite parts that are separate from each other?
Does it matter?
And in the end, it doesn't matter. Well, and in the end, we have a
Because it
continuous
works
experience.
to treat them as both, right?
Exactly.
We can describe
Yeah.
a curve mathematically.
Yeah.
We can describe it as a sum of minuscule
Exactly.
movements.
Yeah.
And so yeah, what
No,
is
exactly.
cool, or
Yeah, exactly. And both have reality to them. And Bergson even says at one point, the infinite is something that can always be looked at from two perspectives, that can be seen as unity or as division, as an infinite number of divisions, or as a simple integral unity, right? And so looking at the intention and the intensive, right? And this idea of the interiority of the curve, where the multiplicity isn't flattened, it isn't destroyed, it isn't uh, turned into a unity or a quantity. It has a living difference within it, even though it's indivisible and unified and connected. Um, so now jumping from that idea of movement and curving and everything in Bergson to this idea in Leibniz. Leibniz has this absolutely fascinating, I love this image. You take a piece of paper and you just put dots on it randomly, put a bunch of dots. You can create a function that is a line that touches every single random dot on that page. So in a way, that this is what our life is like. We have all of these happenstances, we have this unique fingerprint of our life, which is the dots, the different events that have created us. But our inner unity of our soul, our monad, is the function that uniquely touches just those dots continuously, without overlapping, right? And so there's an absolutely simple view, and then there's an infinitely complex view. And the thing of our life is that it's neither the one or the other. It's both, and both describe it meaningfully, and we shouldn't ever go for one or the other by itself.
And so how does he relate this to derivatives and integrals?
So the integral would be the function, right? So like there's this infinite multiplicity of the line that is our life, right? And that line includes an infinite number of inflection points that we could pull out as derivatives. And we can analyze, you know, the moments of our experience. Like I felt pain in this moment and it was a 7 out of 10 or something like that. But it is still connected to, and really only we can really only understand it concretely or integrally when we see it in the flux of the whole and within the simplicity that unites.
So the integral is being the sum of the parts, and the derivative is being the parts.
Yeah, but some in a way that works uniquely to the qualitative, perspectival,
The
monadic
feeling of entirety. Yeah.
Yeah, exactly.
Okay,
Yeah, I
got
think
it.
that's a really good way of saying it. Yeah. Mm-hmm.
Yeah.
Mm-hmm. Yeah.
that was a really beautiful turn right there. And it kind
I
of,
don't know if you have another like question for Kerri something, but we could also open up to questions from the audience.
yes, we could open up the question to the audience, but I have a question.
Great. Yeah.
So um, both of you engage with the aesthetics of math in different ways. Jack, you through music, and Kerri through so many different things, time, but for the sake of this talk, sacred geometry. So how do you see the aesthetic? I mean, Jack, you kind of answered this to an extent right now, but how do you see the aesthetic experience of math shaping our understanding of reality? Like, can the beauty or patterns that we experience in math actually function as a way of knowing? I guess that's kind of a question for Kerri.
Yeah, great question. The kind of going back to this quantification as a way of deepening a dialogue. Once we start recognizing how certain mathematical patterns, whether it be the golden mean or whatever, shows up over and over and over again in nature and in art, in human creations that maybe people didn't even know they were putting into it, or very intentionally put into it, and the aesthetic feeling that is invoked through these patterns that show up again and again, partly because they show up in nature so much, and then we want to recreate things that give us that experience of nature. But it's being able to kind of like see the code underlying what might feel similar, to be able to actually articulate that on a level of precision, that allows you to then see it show up in so many more places. And so I find the exploration is a unifying experience, one that brings us into closer kinship with the natural world and with our own bodies, recognizing how these things reoccur within us and around us, and then that forming a bond between us, and providing fodder for the mystery of why they show up the way they do.
Amazing. Yeah, I totally agree. And I mean, I would say, I think that the way that math, so there's a couple like bigger pillar, or I don't know if pillar is the right word, but like uh areas of resonance maybe. One would be the sublime, right? Like the sense in which the infinite is just awe-inspiring in a way that is at the same time terrifying and exhilarating. Right? Even this like idea that you could put a bunch of dots on a paper and like create a function that perfectly touches just those points in their infinite specificity, can be sublime. It can be this kind of like awe-inspiring, terrifying thing. And hand in hand with that, but slightly different, another one of these kind of centers of resonance is elegance, right? And I think this is like something that comes up again and again, that like when you like strike upon the elegance of a function, or of even just the simplicity of the statement three interior angles adding up to two right angles, which is like the idea of a triangle, right? When you like see that simple statement, which I mean it's wordy, but it's fairly simple, two right angles adding up to three angles, somehow that just like perfectly describes every single triangle. Like that it can strike you as incredibly elegant. Right? And the elegance is a kind of sublime feeling in itself, because the sublime is this level, it's like an order of magnitude, or like a threshold above what we expected. It's something way higher than it hit on a level that was much higher than we expected it to hit on. Right? In the way that it brought everything together, it touches the infinite, but it's also simple. And this, I think we can understand this in a way through like Whitehead and Bergson, and like the aesthetics that they develop with the idea of contrast. When we experience simultaneously something finite and something infinite, that is like far out. That is a crazy experience to have that together at once, right? And something being uh, both complex and simple, right? And I think that this is what why the fractal is so fascinating, right? We see something complex, this form, this patterning, but then we see it repeating on different scales, and there's something utterly simple and nonchalant about it, right? It has like a gestural quality. And I think that in music, we're playing with this, right? And especially the idea of the fractal. I mean, in Western music, a huge like point of resonance is the idea of developing variation. That you take some patterning in sound or rhythm and you vary it, but it's the same pattern under variation, and you see it elongated and shorter and appearing in different and inverted and all of these kinds of weird transformations, and you don't think about it. Like you're experiencing the aesthetic awe and sublimity of mathematical relationships in a just a dynamic, flowing, sensible form. And you identify the same pattern coming up again. You don't have to say to yourself, oh, there it is, I'm cognitively judging it as the same, but you feel it as the same and you work with it as the same. There's a kind of continuity and curvature or spiralateral unity to the multiplicity of interrelated forms. So again, we find, a kind of elegance and sublimity through the contrast of infinity and finitude. Yeah.
Yeah, and I'll just tack onto that one of the key signatures of fractals is this element of repetition and surprise, of repetition and difference, right?
Yeah.
And that's like our neurobiology is conditioned to appreciate that because we like the repetitive because it's familiar and we can predict it and it feels comfortable and safe, but it's going to get boring after a while if we just live in that the whole time. And so then when something novel happens or somebody twists it or does something interesting with it, we're like, yes, what are you doing? We want to do it again to figure it out. That's the dopamine system being engaged whenever something novel happens.
Yeah.
And so there's this hunger, thirst, curiosity to repeat that which is new and make it safe and predictable and comfortable again, and then to find something new again. And so this is just the balance of that back and forth is fun to quantify as another fun way to come up with something new to say.
Yeah. No, exactly. Yeah. Yeah.
That was a pretty damn awesome explanation from both of you. Yeah, so awesome. Well, I'd like to open up the floor for questions from anyone else, if you have any. You could do the raise hand function. If not, I think I have like a bunch of more
And
questions.
I'm just looking through that. There's some that have come through on the chat also.
Erica has two questions. First one is, can you tell us some paradoxes you see in math and time? I make massive breakthroughs in psychology looking at paradoxes, and I am just curious about our points of breakthrough in math, time, and physics.
I mean, for me, the one I talked about earlier of light and time is kind of my favorite paradox, that we know from special relativity that the faster something goes, the slower time goes. And so for photons, which are moving at the speed of light, the speed limit of the universe time ceases to pass, basically. Um, and so there's a perspective from which there is no temporal passage. And therefore, even though we see light as taking 8 minutes to get from the sun to us, light experiences no difference in time or space between the sun and us. And therefore, by experiencing no time or space, there's, just one photon, but we are seeing it in an infinite multiplicity. And so that's one of my favorites, and it makes just an easy transition also as light as the most common metaphor for the divine.
Yeah.
To have this infinite perspective, yet also all matter is made of light, just light being loose energy, matter being bound energy. And so yeah, that's my favorite physics
No,
paradox.
and I mean, I think that I have like the same answer, but it approached in a different in different clothes. And it's really actually the same thing. I mean, like, in a way, like, if we went to Spinoza, for example, who's a huge thinker on the infinite and somebody I love, and like the all substance, God, nature is infinite in just multiple ways. Like, it's not infinite just stuff, it's infinite varieties of infinity. um and everything that is paradoxically sort of pretending that it's not substance or everything. It's in a way canceling out its reality in order to gain its reality, without actually ceasing to be what it is, but also necessarily like negating itself somehow in order to become what it is, without actually severing itself from the infinite, right? I mean, I think that this is the same thing as saying every infinite can be looked at as both a simple unity and an infinitely complex multiplicity. And this tension is actually time itself, and time is consciousness and our experience and our reality. So everything that we experience is a kind of, and this beautiful mind-boggling phrase of an anaximander, where the infinite and the finite are, I'm not even going to get it right, but sort of charading as each other. And as soon as you think you have the one, it's the other one, and they're each kind of canceling the other one out. And that's the play of reality. Yeah.
Yeah, just was reading over notes the other day. I had some point. Matter and light co-create experience by pretending not to be each other.
Exactly. Beautiful. Yeah.
So
We could say the same about body and spirit or something like that.
Totally. All the
Yeah,
dualities. Yeah.
exactly. Yeah.
I see Eddie has his hand up. I'm gonna give the hint to him.
Thanks, Tafshin. Hi, guys. So I was wondering, I was thinking about something, Jack, you said recently about aesthetics arising from the fractal patterns of music, and something you said very early on in the talk about what it means for something to be countable, um, which kind of goes together in this way that, music is extremely countable, whether you're counting beats and measures and all the cyclical things that come up and form greater forms of music. But I wanted to bring that up and then ask you kind of where we then get the aesthetics of music, the emotions and meaning that we get out of music from almost mathematical things, whether it be intervals, which are mathematical, and relationship, like, just want to throw that out there. What you think?
I mean, it's one of the most profound questions out there. And I think that it hasn't fully been answered. And I'm actually writing a book trying to answer this. And I've gotten really into the harmonics and understanding the mathematics of music. And I've always really been into like the mathematics of polyrhythms and complex meters and things like that. So getting into the harmonic side of it is sort of a natural extension of that. But I mean, Leibniz has this great thing where he says, I mean, it's just a fascinating sentence, whether or not it's fully true or not, but that when listening to music, we do unconscious or obscure or occult math. He says something like that. We do this kind of like math in the background where we, you know, when we hear a certain chord, for example, which is like a very basic harmonic structure, we can hear that chord and identify its relationality between the tones in different key centers. So we could play an A major chord and then a D major chord, whatever. We hear it as structurally isomorphic, right? We hear the one chord as a major chord, another chord as a minor chord. We hear them differently. But if we hear two major chords, we hear them as similar, but in different tonal regions. Now, hopefully I'm not getting too far out here, but like you could also take like a 3 rhythm and double the speed so that it becomes like a 6 or something like that. And you hear sameness and difference. We could say the same thing of like the octave. If anybody knows enough about music to know about an octave, you know immediately without judgment that this is an isomorphic form, right? And we know mathematically it's doing a doubling or a halving. So if a beat is going at this speed, then it's going twice as fast, 4 times as fast, etc. That's going to give you an octave. We can look at the mathematics of that. We can understand the fact that the numbers work, but you don't have to do any of that to hear it as patterned and as isomorphic in its pattern, especially with things like rhythm and basic harmony. So, I mean, I want to say that there's a sense in which counting, there's many ways to count, right? You count time without actually literally counting or looking at a clock or anything like that. Like you can feel qualitatively the temporality of it, and you can feel the qualitative difference in 2 beats. You can hear the same rhythm played at 2 tempos, tempi, sorry, and you will qualitatively know that they're different. Now, how do we get an entire language of Western tonal music with all of its cadences and its major and minor dualities and all of this kind of things? That's going to take way more explanation than we can do here. We've been digging into this in my philosophy of music class right now. But what I think is clear is that, yes, Western tonal music, the structures that we have, these things are based on historical contingencies. And yet, the mathematical underpinnings are what made those historical contingencies possible. There's something about the relations between musical intervals that is in the relational reality of the sounds themselves, and the fact that those sounds have mathematical properties to them. There's no world in which the octave is not striking and useful and memorable. Like every single culture understands and perceives the octave as weird and strange. The fact that the same note occurs at different levels and that they're different but the same, like that's such a weird thing that I think we could spend the next 10 years of our lives like focusing just on that and maybe never come to an answer about it, but always be feeling the sublime power of the fact that a qualitative emotional reality comes along with this qualitative and physical reality. Anyway, that's my answer.
And I would just say that there's probably a patterns being reflected, such that harmonious sounds are ordered and nesting well together, and that would
Mhm.
correspond to a feeling that's happy or joyful,
Mhm. Mhm.
because we can access those feelings more when things are fitting together nicely.
100%, 100%. But I would add that there's all these cheeky, weird joys that we get from
For
dissonance,
sure. For
right?
sure.
And they work by like fractal patterning being identifiable on different levels, and in this ability to bring together and again contrast the dissonant and the consonant and these things. But 100%, like those are the like natural basic, like the harmonic series. I don't want to get into the whole, I love the harmonic series. It's this beautiful aspect of nature that any vibrating body vibrates at integer divisions of itself, which is a weird thing. But if you have a string vibrating like this, it's also vibrating like this, and then 3, and then 4, and then 5, and then all of these. And they make basically a symphony of sound. So that if you play a single note on a piano and you like really dedicate your attention to hearing the hidden complexities of this note, you can spend hours unpacking audibly the interstitial complexity of this sound. There's so much more than what meets the ear on our regular hearing of a piano. And you can like, I don't know, really vibe out to a single piano note and hear infinitely rich complexity, because of the harmonic series. And this fits into a whole bunch of other aspects of music that we can't go into now. But there is a mathematical underlying structure to sound, and it's what grants the expressive capacities. And they do have cultural differences and complexities and all of these things, but we're all rooted in the physics of the vibrational reality, this idea of sympathetic resonance, which I think is just, um, yeah. Anyway, such a beautiful notion.
Yeah, and I think it's just interesting because I've been trying to think about like, okay, well, there's music that might evoke anger, right? And it's like, how do we describe the quality of anger? There's like a frustration of something that's unjust or not right,
Mm-hmm,
and there's a lot of
mm-hmm,
energy
mm-hmm,
behind it. And then how do
yep.
you convey that in music?
Mm-hmm,
And there are
mm-hmm,
different ways to do that. And so I
yep.
love the way we're talking about, the subtle nuance just in one note.
Mm-hmm,
And the
mm-hmm,
same thing can be said for like the different valences of any particular emotion or
yeah.
experience.
Yeah.
And when we hear that reflected, even if we're feeling very angry, but we hear music that's very angry, somehow we
Mm-hmm,
feel like better.
yeah. Totally. Yeah. Well, that's the catharsis
Acknowledged,
and the
like
process of it. Yeah.
somebody's on our side. Yeah.
Completely. Yeah. Yeah. Exactly. And that we're sharing this with somebody, and that it's not just like a fluke. It's something that other people have been through,
Totally.
and that we're still
And
together with
that
people.
there's ways to move it that we maybe
Mm-hmm.
hadn't seen.
Yeah, exactly. Yeah, yeah. And I think just really quick, I'll follow that up, that like there's all these things you can do to make music sound angry, right? Like I love metal music. Like you can play fast, you can turn the amp up until it just distorts itself to death, and you go and like all this kind of stuff. But you can also take something very soft and simple, and then try and make it sound angry somehow without doing any of that stuff. And you can succeed, and you can make something really expressive that's very different than metal, that expresses anger in a totally different way. So, and I think that gets at the elasticity of the potential within the physics of sound. Like the physics of sound gives us certain potentials, and that can make us like make really easy angry music through metal, but it can make really hard music to express anger. But when you do, it's all the more incredible and beautiful because you did it through some weird roundabout way that wasn't the obvious way. Anyway, another rabbit hole to go down.
Then we have time for maybe one more question. I have so many, but I gotta leave it open for others.
Oh, yes,
Okay.
I asked, what kinds of things have graduates from PCC done? Like, what kinds of fields have they entered?
Anything and everything. We have a NASA scientist on the call with us today. We have, you know,
It's me.
people Kerri Kapadia. You know, people who just in rich previous careers they came from with new knowledge, people who create festivals, people who are teachers, people who are, you know, infinitely, like there's no one PCC career path by any stretch of the imagination.
Yeah. Yeah, I think like this, like our dialogue right now highlights the way that PCC is all about sort of finding these overlapping spaces where very different disciplines and problems and questions can link together, and like the nexus of questions that comes from, you know, something as simple as what does it mean to quantify and count things, or what is the infinite? You know, like those are two very small questions that then literally can take in art, politics, metaphysics, ecology, spirituality, like, and they all come together and have something to talk about. So yeah, that's the space that we're trying to cultivate.
They bring depth and richness to any field, you know.
Exactly.
I know there's
Yeah.
honey purveyor, there's watershed witness, taking people on watershed tours. There's a pole dancing teacher. There's a, you know, like so many different options. I see a hand up over here.
Can we get this question?
Jenna, go ahead.
Hi. Whoa. Sorry, this is
Nice echo.
echoing. Okay, I just wanted to know, first of all, thank you both so much for being here. I just wanted to know, with what we were talking about with anger and like anger and music, and how every emotion that we're experiencing through music is actually like a micro sort of mathematical equation that we're doing subconsciously. I wanted to know, to take that a step further and to talk about the emotion itself. Like, what is it about anger that feels angry, and can that be talked about with mathematical terms?
I gave that talk at Esalen, my best shot at it anyhow, and it's actually up on YouTube. But you know, one way I kind of took a thermodynamics approach to it, and in my experience of anger, you know, one past experience has been recognizing that I get angry when I've had a boundary crossed that I didn't even know existed. And so it teaches me where I need to actually hold the boundary. And so it's, you know, an incursion across some invisible field, right? But then the talk that I gave, it was more about feeling like I wanted to put something out there that wasn't being received, and there was no place for it to go. So it felt like a buildup of internal pressure. And then the dialogue between, you know, volume and surface area, and heat building volume and heat distributing surface area. And if there's no place for that energy to go, you know, the complexification of the surface area that can release more, blah, blah, blah. I mean, it's a ripe area for speculation, because I don't know of anybody that's done a whole lot with it. So have at it and have fun.
Well, I would plug Spinoza as a deep thinker of emotions and these things. Not that there's necessarily like a clear explanation of how you bridge the quantity emotion gap there, but that's definitely. And I wanted to point out, like, you know, there are very different types of anger, right? And like there's a deep moral, intuitive sense of anger that is like indignation, right? It's this sense of, there's a sense of justice and a sense of a boundary being crossed and these kinds of things. And earlier today I ordered takeout, or I ordered delivery, and it was like an hour and a half late, and I was mad. All right, this was not like a deep moral anger, and like in fact, I was mad at myself for being mad about it. I'm like, wow, how much of a consumer like piece of shit am I for being mad about my delivery being late, So I do think like there are isomorphisms there, right? Like I don't want to say I was like turning red in the face or something like that, but I had the physiological like tension and heat and these things. So just to say that like uh every emotion can have similarities to other emotions and can share something in common with them. And there can also be like two forms of anger that are the worlds apart. One is this like morally questionable anger that I had earlier and that I chastised myself and felt remorse for, right? And then there's like a very profound and life and world changing anger, which is indignation, right? Anyway, just scratching at an idea and like plugging again my Spinoza class, which will be next spring, where we talk a lot about emotions.
Well, thank you both. That was so amazing. And gosh, so many things to talk about. I can't wait to rewatch this on the PCC Forum YouTube channel. And if anyone else is interested in diving into these topics, Jack will be holding a philosophy of infinity course in the fall, and Kerri will be giving her sacred geometry, archaeoastronomy, and modern physics. I believe all three of them over the summer. So
Three separate courses. Yeah.
three, yeah, right. Three
That are
separate. Gosh,
available, yeah. And I am going to do Texture of Time through PCC in the fall. And modern physics is a great ramp up for that.
It is. I've taken both of them and I love them. So reach out to her for the summer courses. And yeah, everyone, thank you so much for joining. Thank you, Jack and Kerri, for your time. When will this be posted? I think hopefully by tonight, if not tomorrow. I'll try to get it up, but yes, it was a brilliant dialogue. So
thanks so much for bringing us together, Afshin. Appreciate the opportunity to chat with you, Jack. And yeah.
Yes, thank you, Afshin, for organizing this. And Kerri, this was such a generative conversation. I feel like we've just gotten started on something that needs to continue. And
yeah, right on.
I could envision a co-taught course at some point weaving these things together. So
yeah, sweet.
beautiful.
That'd be great.
all right, everyone. Once again, thank you, and
Thanks, Afshin.
you have a good
Thanks
night.
everyone for being here.
Thanks, everybody.
And we'll see you at the next one. Take care.